Okay, so last class we talked about how we can use the sine function to find missing information in terms of angle measurements and the measurements of the lengths of sides of a triangle. Now so far we've talked about trig functions, sine, cosine, tangent, all being functions that you can use with the right triangle. Now what we did in the last class is we talked about how you really can take any triangle and then bring down an altitude line, and lo and behold, you end up with two different right triangles. And then you can start using your trig functions again. And so we looked at a triangle like this. In this case, we have a scaling triangle. All three sides have totally different side measurements, and same with the angles. And I was trying to introduce the law of sines as another way to organize your information that you receive about a triangle to find missing sides or missing angles. But you were resisting the idea because you knew you can find the same information just with what you already know, just by using a simple sine function. So let's go ahead and take that process you were using the sine function, and I'll show you how you can how that same process you were using evolves into the law of sine. So it really doesn't make any difference which way you go. So for instance, in class we did sine of angle C is equal to the side that's opposite it, which in this case, because we drew an altitude line, we're talking about this triangle here, so we're going to say it's H is the side opposite, over the hypotenuse. And since this is the right angle, this is the hypotenuse. Alright, now if we do the same thing with angle B, then we're just going to say sine of angle B equals this side opposite, which again happens to be H, even though it's a different triangle, over the hypotenuse, which in this case is going to be C. Now if we just rearrange these equations, we can make them both equal the same thing, which happens to be the height. So what I'm going to do on this equation is I'm going to multiply both sides by b, and what that's going to do is that's going to cancel these two out, and over here I'm going to get b times sine of c equals h, and over here I'm going to multiply both sides by c. That's going to cancel those out, and that's going to get me c times sine of b equals h. Okay, so now I have these equations, two different equations, but they equal the same thing. So that means I can make them equal to each other. So I'm going to do that. Equals c sine b. This, by the way, is capital. And now they're equal to each other. All I'm going to do is I'm just going to reorganize the information here a little bit differently, just so it's kind of into a more friendly formula, which is going to end up being the law of sines. So what I can do is I can divide both sides by b. And when I do that, these will cancel out. I'll end up with sine of c equals c times sine b over b. And then I'm going to do the same thing on this side. I'm going to move that c over. So I'm going to divide this whole side by c and that side by c. And what I'm going to end up with is these canceling out. And then what I will end up with is a nice and a bit more friendly formula to remember. Is that. And this is part of the law of sines. The only thing that's missing here is just because we just didn't do that angle. We can, though, if we just drop a different altitude line or a different height line, we can do the exact same thing, and we'll end up with sine of A over A also equals one of those two ratios, depending on how we begin our whole process. So even though you were resisting using the law of sines, you actually were using the process you were using would get you here anyway if you just did a little bit more algebra and you turn it into these ratios that are nice and friendly to remember. Alright, so let's talk about why we could use those and why life really could be a little bit easier if we use those formulas. So I'm going to write the formulas up here again, or shall I say the law of sines. Oops, there it is sine of A over A also equals sine angle B over B, which also equals sine angle C over C. Now, by the way, we can put these ratios in the opposite direction. If we wanted to, we can put A over side A over sine of angle sine A. Angle sine A. whatever. And then B over sine of angle B and C over sine of angle C. All right, we can pick either way. It's just that if we're going to pick these ratios, then we better keep them consistent. We're going to put the measurements of the sides on top in the numerator. Then we should do that with all the ratios. You can't mix and match. The same up here. If we're going to put the angle measurements in the numerator, then we need to keep them the same with all three ratios when we're comparing them to help us find missing information. Okay, so I'm going to recreate our triangle that we had. And this time I'm going to give them some measurements. So let's do a similar scalene triangle, just so we can see it works with any triangle. And this time I'm not drawing an altitude line, because we don't need to, because we're going to just use the law of sines. But I am going to label these similarly. Just makes life a little bit easier if you just always label your triangles when you're dealing with trigonometry as ABC, because the formulas tend to be written in terms of triangle labeled this way. Alright, so let's say I am given, oops, where are my sample numbers? That I am given that angle A is 79 degrees, and I'm given that side A is 11 units of some sort, and I am given that angle B is 34 degrees. And let's say that's all I'm given. Yes, if I want to, I can drop an altitude line and I can do what we did in class last. But now I'm just going to say we have to use the law of sines. And if we're going to do that, then what you can do is we can see that we have all the information we need for the ratio with angle A and side A. So let's go ahead and form that. Sine of angle A over side A equals sine of 79 degrees over 11. And that's one ratio I've already formed. Now, I have another measurement here. I need to form another ratio. Now, since the measurement pertains to one of my B letters, I'm going to go ahead and use one of these B ratios. And I like to use the angle on top. I'm going to use that one. So I'm going to say that this ratio equals sine of 34 degrees over side B. That's the missing information in my ratios. Now, since if I'm only going to use these two ratios to compare, I've got to have at least 3 of the unknowns completed. I've been given 3 of the unknowns, and all I have to do is just solve for the last one. I would not be able to solve for anything if I had 2 unknowns out of the 4. But because out of these 4 spots where numbers can go, I've got 3 of the numbers, and I'm missing only 1, I can solve for B. So now I just use some algebra, and I think the easiest way is to use cross multiplication. And so what I can do is say this times this equals this times that. Just basically make another equation that is equivalent to this one. So sine of 79 degrees times B is the same thing as writing B times sine of 79 degrees. So this times these two multiplied equals these two multiplied. 11 times sine of 34 degrees. It is a lot better to write, when you're multiplying something to a sine function of a number, it's better to write that number in front, like this, 11 sine 34. It's not good to write it, for instance, as sine 34 degrees times 11. It gets confusing, and you're not sure, oops, you can't barely see it. It sometimes can confuse your reader. You're not sure where this 11 is going. Is it going in with this sine function, or is it number being multiplied to all of that? So it's safer to put it out in front. Anyway, so now I've written an alternative equation that's equivalent to the way I wrote them here in terms of ratios, and the missing information that I need is B, so I'm going to solve for B. So to do that, I have to isolate B. I might as well divide this sine of 79 degrees on both sides, so that way I can eliminate it on this side. Those two will cancel out. And what I'm going to end up with is B equals 11 sine 34 degrees over sine 79 degrees. And now you can use your calculator to figure out what that would equal.